All right, guys. Welcome to this video. I forgot to record last week's lesson or this week's lesson, so I'm just gonna do a quick video rundown, and it'll kind of help weed out and let you just focus in on the lesson. I'm gonna during the lesson we recoded all of this, but I'm gonna start with it typed out just so we don't just to speed up the video a little bit. So let's get to it. The goal of this code is to determine the poverty rate impact for various levels of spending on a child allowance. So if you watched the other YouTube video, we looked at the poverty rate impact of just one level of the child allowance. Here we're going to look at multiple levels all at once so that we don't have to keep changing the number, and we can eventually put this into a nice chart that is easy for people to read. And I actually want this to be the child poverty rate. We're going to look at child poverty this time. So I just typed the goal here in Colab. So however you want to do this, if you just want to watch and try to soak in what the code means, or if you want to follow along and try to create your own code, that's probably what I recommend. Just getting used to typing this out, I think helps. So let's go through each of these lines of code before we start adding new code. The first step is we always want to import our libraries that we're going to need. And it's just a good habit that you're probably going to need NumPy and pandas for all of the, pretty much any project you do in data science project you do in Python. So NumPy kind of makes it easier to work with numbers and arrays. And pandas is the go-to data science library. You can see we kind of use it right away down here. We're importing NumPy as NP, which means anywhere I type NP, I'm calling the NumPy library. And anywhere I type PD, I'm calling the pandas library. So we start by importing our libraries, and don't forget to play it once you import your libraries. And after you import your libraries, it's always good to import your code. I will put the link for this code in the YouTube comments, though I think there's been some issues with that before. So I can also include it in the email that I'll send out with this. So when we import our code, we want to first name our data frame. Okay, our data frame is essentially, you can think about it as the table with column headers. You have your index that identifies the rows, and then you have all your information inside of there. So the data we're importing is the 2019 ASEC data, which is collected in 2018. So it's essentially 2018 data. And I'm importing it from Max Guinness's GitHub using this link. Again, I'm eventually going to show you how to upload your own data onto GitHub. So just kind of think for now, okay, we're importing all of this data off of GitHub. The ASEC survey has about 180,000 people on it and 75,000 households. And it has about 799 data points on all of them, I think. So we don't want to actually import this entire thing, because if we did, it would be a really long mess, and it would just kind of overwhelm our data, and we don't need all the data. So we're going to use this useCalls function to specify the columns that we want. So just to note on the syntax, you're doing whatever you want to name the data frame. I named it person_raw. Then you use pd.read_CSV to say, hey, pandas, we're going to use pandas to read a CSV file. And then we have Max's CSV file here that contains all the data. We have a comma that, after that, and then we call the useCalls function, and we use these squiggly brackets, which I should learn a better name for. So here's each that we're calling the Mars UPWT. I think this Max told me the other day, it stands for the March Supplemental Weight. That's what it stands for. It's essentially the person's weight. So every person has a weight. There's 180,000 people in the data set, but there's over 320 million people in the United States. So each person is weighted to represent a certain amount of people. And based off your characteristics and your demographics, you might represent more or less people than somebody else in the data set. So the weight is imperative to making sure that our data makes correct predictions. Then we have the SPM ID, which just says what household they're in, essentially. This is their household ID. We have their SPM resources, which is their post-tax and transfer income. We have their SPM poverty threshold, which is just says how much money does this person need to have as their SPM resources to be above the poverty line. We have their age, and then we don't actually need this, but I just put it in anyway in case we want to do deeper analysis, their race. I don't have all of these memorized, and you definitely don't need to. I just have this, I use this data set a lot, so I have all the variables saved on here. So, I know if I want to use, I need to use their poverty threshold. I can start to type poverty threshold, and boom, it's right there, right? Their SPM poverty threshold. So you definitely don't need to have these memorized, just know where to find them, or just, for now you can just enter in what I entered in. Then we create a copy of our data set just so we have this raw copy of unchanged data, and then we have our data frame that we want to change. So I'm naming a new data frame person in this line, and I'm saying make a copy of person.raw or person_raw, and deep equals true just kind of means capture all the data. Then we're going to use these are all capitalized here, so I don't like dealing with the all caps. So what I'm going to do is I'm going to use person.column. So I'm saying, okay, take all of these columns, and take their strings, these are all strings, and make them lowercase, right? That's what the lower function does. If I used upper, it would make them all uppercase, but they're already all uppercase, so I want them to be lower. Okay. Now this next line of code here, this weight isn't the person's true weight, the Mars UPWT. It is their weight multiplied by 100 to get rid of decimals. But we don't want to multiply it by 100. We want it to be the exact prediction of the amount of people in the United States. If you used this as the weight, it would predict 32 billion people in the United States. And there's 320 million people in the United States. So we want to divide it by 100. Right here is a very important thing to understand what's happening right here. Is we're creating a new column in the person data frame. When you want to create a new column, you type the data frame you want to create it in. And then in brackets, you type the quotes, you type the string that you want to name that column. So we're naming this column weight. Now, what is the weight column? The weight column is this column, the original Mars UPW weight column. So we can call that column person. We're saying in the person data frame, call the Mars UPWT column and divide it by 100. So if I play this data frame person now, I can see now I have a weight column that shows the calculations, which is exactly what I want. And let me just... Now this next column just said this is kind of a new trick just for you to have. Now that I've created this weight column, I don't really need this Mars UPWT column anymore, and I'm just going to get rid of it, saying delete DEL in the person data frame, this column right here, and it'll delete it. It can be pretty helpful just to put that in a different code box so it doesn't end up deleting this before we can use it. Okay, so we have created our person data frame so far. And the next step in this part, I think, is the most confusing. It's even more confusing than the for loop. I'm going to go through it kind of quickly, and I'm not going to get caught up in the syntax. Basically, first we want to know who is a child. If we're going to make a child allowance, we need to know, and we're only going to give it to children, we need to know who is a child. So I'm going to create a column in my data frame. And I actually think, let me delete these. I actually am going to go through this with you, this part. Psych, changed my mind. So first I want to determine who is a child. So I'm going to create a child data frame. And you should be thinking, column, in your head, how do I create a child column in that data frame? So just, try to think about it. And a person is a child if their age, so we want to call the age column in the person data frame, is less than 18. That's how we determine if a person is a child. We don't need to know who's an adult, but I'm just going to code this so that you can use the adult column if you want to practice making your own for loop at the end. So we're going to call the we're going to create another column called adult. That's going to be a Boolean value. So these are true or false. Is this person an adult or not? And a person is an adult. Sorry, person.age. If their age is greater than or equal to 18. So now if I play my data, I should see a true or false column, a Boolean column. Boolean means it's true or false. If a person is a child, and a separate column is if they're an adult. So let's play the person data frame. And now I see, okay, this person's age is 15. So yes, they true are a child, and false they're an adult. This person is 21, so false they're a child, true they're an adult. So that looks like it's working. But I want to group people by their SPM ID. And the reason for that is, and I just want you to think about, let's think about just a single mother and a child. And let's say, that family is living on $12,000 a year right now, and their poverty threshold is $15,000 a year. So there's a $3,000 gap between their poverty threshold and their actual and post-tax and transfer income. If we give a $6,000 child allowance out, that raises that whole family's post-tax and transfer income. We're assuming they share resources. That raises both the mother and the child's post-tax and transfer income to $18,000. We've not only lifted the child out of poverty, but we've also lifted his or her mother. We want to group people and figure out how many total children and how many total adults are in their house. So when we give benefits, we know that we're raising the whole household out of poverty if we cross that poverty threshold. So I'm going to create a data frame ages, and I'm going to use the group by function here. Okay, so I'm going to say I'm grouping people in the person data frame, and I want to group them by their SPM ID. Remember, this is their household number. So I should have left a table up, but people with the same SPM ID number, that means they live in the same household and they share resources. So me and my brother we live in the same household, but we don't really share resources. So we wouldn't have the same SPM ID. So, we do, but we probably just would, okay. So now that we want to group by the SPM ID, what do we want to group? We want to group the child, and we want to group them by adult. I'm going to run both of these. And what I want to do is I want to sum up the total children and total adults in each household. So if it hits true 3 times for child in the SPM ID, each of those true have a value of 1. 1 plus 1 plus 1 is 3, and it would say, okay, they have 3 total children in their house. So we want to name those columns accordingly. We just created the 2 columns in the ages data frame. One named child, which totals the amount of children, and one named adult, which totals the amount of adults. But that's not really, the name child for the total amount of children isn't really accurate. So what we're going to do is we're going to rename the columns. So I'm going to rename, and I want to put total, this is total children, right? That's what it really is. And the order matters here, because child was first here, it needs to be first here. And total adults. So now if I print the ages data frame, just to give you a look, I'm kind of addicted to rerunning everything. You probably could have just reran this cell. But if I print the ages data frame, now I have a total children and a total adults column. Good, that's what I wanted. But I want these columns, I don't want to be in the ages data frame. I want them to be in the person data frame. So I'm going to merge them all together. So we want the person data frame to be equal to the person data frame merged with the ages data frame. And then these next parts, I'm going to merge it on the SPM ID. That's how we're going to make sure that people get back to where they're supposed to be, by merging people based on their SPM ID. And also use right index equals true to make sure the index is all set. So now if I play the person data frame, it should have merged those total children and total adults columns onto the person data frame. So look, we have a total children and we have a total adults column. So this tells us that this family has 2 total children in their household and 4 adults. It's a really big family. This family has no children and 2 adults, right? So you can kind of see the breakdown. Now, just every time I play this person data frame, let me read. It's showing me the same people. So if you just want to look at a random sample of people, if you do the data frame, which our data frame is named person.sample, and let's say we want a sample size of 15. Now, if I play this, I should start using Control F9 for the rerun all, but I guess it's helpful to click so you can see what I'm doing. It just gives me 15 random people in this data set and kind of gives me a little snippet of their life, their race, their age, their poverty threshold, their resources, how many children, how many adults live in their house. Okay, so now that we've created that, our next step is just to do some quick stuff with population. We really could put this in the loop, but I think it's beneficial to put as many things outside of the loop. If we're going to figure out the child poverty rates, the denominator of that rate will be the total amount of children in the country. So we need to figure out how many children are in the country. To do that, we're going to calculate the total. We're going to tell the children population, and that's going to be equal. Let me slow down for a second. Let's do the total population first, so that we can make more sense of this. The total population is going to be equal to all the people's weights summed together. And that should predict the total population in the United States. If we take every person's weight and sum it up, that's what the weight is doing. It's saying this person represents X amount of people, this person represents X amount of people. And eventually, if you sum all of those up using the sum function, it should tell us the total population. So if I print the total population, it's about 324 million that this data set predicts. And we know, if you know anything about US demographics, that's very spot on, so we can be pretty confident in this data. So now if I want to do the total children, not total children, I'm going to call it children population. If I want to do the children population, well, I want to use everyone's weight, but I'm going to put this in parentheses. I want to take everyone's weight and sum it up, but I only want to count the children. So if I take this and I multiply by the child column and sum it up, this was the correct equation, but let me explain this. This is saying take everyone's weight and multiply it by the person.child column. The person.child column is a Boolean that is either true or false. True has a value of 1, and false has a value of 0. So what this is saying is, if a person take a person's weight and multiply it by either 1 or 0. If we multiply by 1, we just keep their weight. We didn't change their weight at all. But if they're not a child, if it's false, they're not a child, it'll multiply by 0 and essentially negate that person from the data set. So we can kind of use this Boolean to only include people in our weight, or only include child in our weight. So now if I print the children population, I probably made a spelling error, and I did. I didn't include I here. It's about 73 million, and that looks good. So now would be maybe a good time for you to pause the video and try to make the adult population on your own. I'm going to get right to it because I'm assuming you paused and unpaused. But it's good to just practice solving these things on your own. So let's make the adult population. Again, we don't need it for our for loop, but this is just if you want to write another one after. The adult population is equal to the person's weight times, if they're an adult or not, we want to include them. We sum it up. And there you go. We can print the adult population. Okay, which is about 250 million. And these two added together should be exactly this. Okay, we are ready to dive into the world of for loops. So I'm going to add a text box and say, run the loop. Now let's get ready to code it. we're going to use a for loop, and I think it's best if I just start typing it, that runs different levels of spending for a child allowance. So for spending in the range, so what this is saying so far is, well, no, let's just type it all out. No. So for spending is now a variable. And we're going to say, in what range do we want to run this loop for spending? Well, I want to start at $0, and you always start where you're starting. So the first column, or the first number you're putting in the parentheses is where you start. The second number is where you want to end. And I need to learn how to do this in scientific notation. I don't know why it gives me an error when I run scientific notation. I keep meaning to look into it and not doing it. I want it to end at 500 billion. So I'm going to type 500, and you can use underscores as commas to kind of like keep track. 500,000, 500 million, 500 billion. But what's a little bit tricky about Python is that the first number is inclusive, which means it's going to include 0 and start at 0. But the second number is exclusive, which means if I end at 500 billion, it won't include 500 billion. So if I wanted to include 500 billion, I should type 500 billion and 1, because it does not include 500 billion and 1. And the third number is the interval at which you want to go. I want to go at $50 billion intervals. So I want to say, what if we spend $0? What if we spend 50 billion? What if we spend 100 billion, and so on? So I'm going to use a $50 billion interval, 50,000, 50 million, 50 billion. And then we end our first line of the loop with a colon. We enter down, and now we're going to start typing in this loop. So the first thing we want to do, remember, we're looking at a child allowance. And a child allowance here is just going to be, I'm going to use CA for child allowance, equal to the total spending divided by the children population. And let's just make intuitive sense of it. The total child allowance that every child gets is equal to how much we spend on a child allowance divided by the children population. So just imagine for a second a really small economy with 2 children. If we spend $100 on a child allowance, so spending is 100, and the child population is 2, then the child allowance amount would be 50. It's obviously we're working with much bigger numbers here. So now we've created the child allowance, and we want to make sure that people who have multiple children get the child allowance multiple times. So I'm going to create a new variable inside the person column, or inside the person data frame, their total child allowance. So how much do you get total from the child allowance benefit? And that's just going to be equal to a person's total children multiplied by the child allowance amount. So if the child allowance was 5,000 and the person had 2 children, then it would multiply those together and they'd get $10,000. Whoop. Okay, so now that I know how much each person is collecting in a child allowance, I need to figure out their new SPM resources now. So a person's new SPM resources is going to be equal to whatever they had before, whatever their SPM resources was before, plus their total child allowance amount. So if we add those two together, that'll give us their new child allowance amount. So now let's determine who is still in poverty. Given a child allowance, who is still in poverty? So to figure out who's still in poverty, I'm going to create a column that's just a Boolean true or false. Is this person poor or not? And the way we determine is a person is so poor or not is, are their new SPM resources less than their poverty threshold, right? If their new resources are less than their poverty threshold, then they are poor. If they are greater than their poverty threshold, then they're not poor. So this line kind of says who's still in poverty. Great. Now that I know who's all in poverty, I need to figure out how many total children are in poverty, because we're trying to figure out the child poverty rate. So let's figure, if you were trying to figure out the overall poverty rate, you would figure out all of the people in poverty, but we're focusing on the child poverty rate. So I'm going to say, no, I'm not creating a new column in my data frame, I'm going to create a new variable called total child poor. And this variable should tell me how many poor kids there are in America for each spending level. So to do this, we want to take every single person's weight, but we only want to count them if they're a child, right? By multiplying by the Boolean. And now we also only want to count them if they're poor. So we're multiplying each person's weight, but we're saying only count them if they're a child and only count them if they're poor. And then we want to sum up all of those people we just counted. So this is saying, add up all the poor children. Now that we know how many children are in poverty, and up here we calculated the total child population, we can easily figure out the child poverty rate by saying, take the total child poor divided by the children population. And there we have it. This for loop calculates everything we need to know. Inside the for loop, we need to use the print function. So I'm going to tell it to print the child poverty rate. So if I'm just going to rerun everything. No promises there won't be any errors first time I do it. Could be a typo somewhere. But it should print the child poverty rates for each spending level. And it does, so it worked. So eventually we're going to learn how to put this into a nice table, but this is a good final product for now. It's saying if we spent $0, so what is the current child poverty rate? It's 13.6%. And if you want to turn these into percentages, you could just multiply this by 100 to make it easier to read. Okay, the child poverty rate is 13.6% if we spend $0. If we spend $50 billion on a child allowance, then it drops it to 11.8%. If we spend $100 billion, it drops it to 10.1%, and so on and so on. If we spent $500 billion, it would drop the child poverty rate to 3.2%. Now, if you said, oh, I want to get the child poverty rate even lower than that, how much would we have to spend? You could check, you could change this to 800 billion and then rerun the loop. Okay, at 800 billion on a child allowance, we get to 1.65% and so on. You can always change the loop. I'll change it back to 500 billion because that was the original policy exercise. So that's basically it from me. What I would say is I'd give you a challenge from here to try on your own, and then I'll just give you the code. Is try to create a for loop that calculates the overall poverty rate on various spending levels on an adult UBI from $0 to 1 trillion at 100 billion intervals. So what I'm asking here is saying, if we had an adult UBI, find how that affects the overall poverty rate at $0 of spending, $100 billion of spending, $200 billion, $300 billion, $400 billion, all the way up to 1 trillion. So that's the prompt, and I think I should have double checked, but I think I already wrote that code here. I did. So I'm just going to leave this code up for the 10 seconds so that you can pause and take a screenshot or just whatever. I would use this to check your answer. I would not look at this. I should have said that before, but try it first on your own and then use this to check your answer. So that's it. I hope this video helps, and as always, reach out with any questions.